experiment separation of quinine from cinchona bark. Here we have a cinchona powder and all the other things which are related, which are required for the separation. I'll tell you in brief what is the procedure. Now, cinchona bark contains cinchona alkaloid. There are 4 alkaloids: quinine, quinidine, cinchonine, and cinchonidine, of which quinine is the most important and which has been used as a antimalarial drug, and it is also standard beater. Now, in plant it is present in the form of a salt, and those are normally hydrophilic. So what we are going to do, we are going to treat this with a alkali. So here I have a calcium hydroxide, which is an alkali. So what we will do, we will impregnate this powder with the calcium hydroxide, and then we have to keep it for half an hour, so that this calcium hydroxide should go into the cell and convert that alkaloid into a free base. Okay, because then half an hour we have to give it, because when we do the powdering, in powdering you are not damaging the cell, you are only damaging the tissue part of it, and that is why extraction needs longer time. So we are going to imbibe with the calcium hydroxide, and thereafter we are going to extract with the toluene as a solvent. So once it gets converted into a free base, it will come into the toluene, then it becomes lipophilic. So we are going to extract with the toluene, and thereafter in toluene some impurities will come, lipid impurities will come in that. So then what we will do, we will extract in toluene with sulfuric acid solution. So then it will get converted into a quinine sulfate, and the lipid impurities will remain behind actually in toluene layer. That we will carry out in a separating funnel. Okay, and thereafter we will precipitate that sulfuric acid solution, which was containing now quinine sulfate, with addition of the sodium hydroxide solution to the pH of around 5 to 6. There quinine sulfate will get precipitated. So we will be doing the precipitation in the acidic range itself, not in the basic range. So acidic range, it will remain in the sulfate form itself, and that will get precipitated, dried, and if the need arises, you can even purify that. But before that, what we are going to do, we are going to ascertain whether quinine is present in a bark, and that we will be doing it actually with the help of TLC. So please come forward. So here we have a standard quinine. So add methanol into this and prepare a solution of this. And we are going to prepare solution of cinchona bark. That is a standard quinine, and this is cinchona bark, to which we have added methanol, and I am going to heat it to facilitate the solubility of quinine alkaloid in methanol. Okay, so now we have both standard quinine as well as extract. We are going to spot the TLC. Put it there. Yeah. Once again, left side I am putting the standard. And here's an extract. Okay. TLC plate is ready. We are going to develop it with the help of mobile phase, which comprises of chloroform and diethylamine in the ratio of 9:1. Please put it in this around 3 ml, and then with the help of the forceps, put the plate around 3 ml. That is enough. In meantime, we can do one test. Continue. Quinine alkaloids are having the advantage that they are, when treated with the sulfuric acid, they use bright blue fluorescence. So we'll try to see whether it is giving the fluorescence. Get the filter paper. What is this? One extract of water and put it acid. Can you see the blue fluorescence in the left bottle, left test tube? There's a blue fluorescence. On the right, To my right, huh? Are you able to see fluorescence? This is a UV lamp, and you can see there's a blue fluorescence in this test tube, but there's no blue fluorescence here. Okay, this is a test for quinine. Are you able to see the blue fluorescence here? Or otherwise, if you have a UV here, this is a UV. Okay, capture it here. Come. Something to keep slanting. Yeah. You can capture from here. No. Are you able to see? No. You are able to see here. Can you see the fluorescence? You can see on the right side it is giving the fluorescence because of the alkaloid. Do one thing now. आता capture करो. Take out the plate. Take out the plate. Take out. With the forceps plate. Yes. Okay. Dry it. Dry it with the help of the dryer. Done? Okay. Now, this is sulfuric acid with methanol. So we are going to treat this with this. Yeah? So can you see now? In the TLC plate, you can see the fluorescence. On the left track, it is a standard. On the right track, it is a test material. Okay, that means our sample has quinine in it. Okay? Yeah, you can capture in case if you want in UV further. Okay, all right. So now we have confirmed that it contains quinine. आता आपल्याला एक ट्रे लागेल. चांगले असते त्याच्यामध्ये. TLC दिसतंय बरोबर? हां? Put it here. Put it all at once, quick. Okay. Now you add calcium hydroxide solution. Triture it now. This you triture it. I'm going to add. Make a veil. Triture it. Put a little more water. This water. All right. Get some more calcium hydroxide. Put it. Where is the filtered one? Starch? Where did you keep it? I did. Array, first class. You're fast forward. Huh? Very good. Put it in there. And both of you stand there. Show the product. Huh? First class. Skip it. It has become weight. Very good. Add. No problem. Add. Where are these two students? Both of you, I mean, you capture. आपण अरेंजमेंट करू आता. नेक्स्ट असेसमेंटची. जास्त वेळ नाही आपल्याकडे. चाय वाले कौन है भाई? चाय वाले? चाय की पत्ती कहाँ पे है? हाँ? आणि मी ते एक फिल्टर बॅग Cinchona powder which was treated with the calcium hydroxide. Now we are going to add toluene in that around 500 ml and then reflux it for half an hour. Okay, please add toluene in this. 500 ml. 300 टाका, 300 ml टाका. Go ahead. Put around 300 ml. Okay, we have put actually toluene in this. Now we are going to reflux it for half an hour. Put it. काही स्टँड पण लावायची आवश्यकता नाही आहे. Hit it. Start hitting. Okay. Very slow because it is a high boiling. Toluene is a high boiling, 110 degrees is the boiling point, so don't bother about that. Very low circulation of the water is required. Okay. Now we are ready with the extract. This is a Cinchona bark which was impregnated with the calcium hydroxide, and thereafter we have put the toluene as a solvent, and then we allowed it to reflux for half an hour. So hopefully now the quinine has got extracted into a toluene layer. So we are now going to separate the toluene layer, and thereafter the toluene layer will be treated with the sulfuric acid. So get separating funnel here. Separating funnel. And stand. Okay. Cotton. So I am going to filter now the toluene layer. You can take one test tube and confirm whether the quinine has come in this or not. Take one test tube. Add sulfuric acid, 10% sulfuric acid, just 5 to 7 drops in water. And then see under UV. Okay, put water now, half a stick of water. And see under UV repeating the process. Repeat the process identification. Yes. Good. You repeat the product. In the Cinchona bark, I am just covering the toluene layer. So now we have to put the toluene layer with sulfuric acid. 20 ml portion, 2 portions will be taken of sulfuric acid. Sulfuric acid in water, 20 ml, 2 times. 100%. Not 20%, but anyway. We change it. This is sulfuric acid 10%, so we are going to treat this toluene with sulfuric acid. keep it. And I want 20% sodium hydroxide solution. 20% to 40%. And dropper, and then I will stir. So you can see here sulfuric acid from the lower layer, upper layer is of the chlorine. So we are going to separate the sulfuric acid layer. We are going to treat once more with the 20 ml of sulfuric acid. So that you guys will not be able to keep it in this. Down. Try the sodium hydroxide. Sodium hydroxide you should never put it in the dark water and stop. Do not get it here to break the bottom.